Welcome back. In this video, we're going to analyze a new type of movement using a projectile movement component. So we're here on the fifth panel, and we have a pair of actors here facing each other. We can right-click and edit these blueprints to look at them. This is BP ball projectile movement. Now, notice here we have nothing in the event graph, but we have projectile movement, a projectile movement component with an initial speed of 200 and projectile gravity scale of 0. Now, if we select our ball mesh, we can see that we have simulate physics checked. So these balls are simulating physics. Now, what happens when we're simulating physics with the projectile movement component is the initial launch parameters of our projectile movement component will affect the ball mesh, and then the movement will be handed off to the physics system. So let's see what happens when we press play. They bounce off each other just like they did when we added force in the panel to the left. So the projectile movement component is capable of checking its updated component, the component that it updates the position of every frame. And if that updated component, the ball mesh, is simulating physics, then the projectile movement component will simply launch that ball mesh as if we had added a force to it. Now, if we go over to the sixth panel, we'll see that this one says projectile movement component not simulating physics. So we have the same exact class, BP ball projectile movement component, but if we select the ball mesh, we can scroll down and see that simulate physics is not checked. And that goes for both of these actors. So let's see what happens when we press play. We can see that they just bump into each other and stop. This is the same type of result as we saw when using add actor world offset and set actor location using sweeping. That's because the projectile movement component in this case is moving the updated component with sweeping. That's why we did not get a bounce and the balls did not fly in the opposite directions once they collided. But we can go into our projectile movement component and change some parameters. You see there's a should bounce Boolean. If we check that, make that true, then we can press play and we see that they bounce off of each other just like two objects simulating physics. But the cool thing is they're not simulating physics. It's the projectile movement component that's simulating that bounce. It's updating the position every frame as if there was a bounce force, sending those objects away from each other. So the projectile movement component is sort of faking it. It's acting as if there was a physics force, but there is not. And the projectile movement component has a bounciness parameter. It's set to 0.6, and if we increase that to, let's say, 1, then we'll get even more bounciness. And you can even set that to a value greater than 1, which means that the object will bounce with even more force than it initially had before the collision. I'm going to set that back to 0.6, however. Now, when the updated component is not simulating physics, I mentioned that the projectile movement component moves that component with sweeping, but the projectile movement component has the ability to not sweep as well. If we scroll slightly down to projectile simulation, we'll see that we have sweep collision. If we uncheck that, now these objects will not move with sweeping. And because they're not using physics either, well, let's see what happens. They pass straight through each other. Because now that they're not using the physics system, they have to rely on the query system. And if we disable sweeping, well, they're no longer detecting the blocking collision with the query system either. So you need one or the other if you want these objects to block each other. If they're not simulating physics, you'll need sweep collision at least. And if they are simulating physics, then sweeping doesn't even matter. I can turn sweeping off for the projectile movement component and go back to my ball mesh and make sure that it's simulating physics. I can do that on each instance as well. We'll have them both simulate physics. And now they're not using sweeping at all, but it doesn't matter because they're using physics. So they will bounce off of each other. So it's important to understand the difference between the physics system and the query system. If you're using the physics system, you don't have to sweep. If you're not using physics, then you do have to sweep if you want collisions to block geometries and prevent them from overlapping with each other. So that's how the projectile movement component works. And the various movement components in Unreal Engine are quite sophisticated. We've seen the floating pawn movement component, and that moves our components using sweeping, and the character movement component, which is a little bit more specialized, also moves the character that it's connected to with sweeping as well. An object can participate in both the physics system and the query system, and that's why a primitive component with collision can have its collision enabled setting set to collision enabled query and physics. So the setting that you choose really just depends on your use case. If you need both, you can have both, but if you only need physics or only need queries, you can use one or the other as well. So this gives us a little bit of a look into how collisions work, at least with blocking collisions. Excellent job, and I'll see you in the next video.